Get your hands in the air for a special report. Motherfuckers, you know it's a special report. Welcome to this week's special report. This week we have a new configuration going on. I'm layperson Graham. This is Dr. Greenfield. Now to give you a little background about this guy, he has an enormous fucking IQ. I mean, that's like about 300. I don't even know if they count that high. He's gotten A's in every class he's ever taken. I mean, even classes he hasn't taken, like the interpretive dance teacher will just throw A's at him when he walks down the hall. You know, it's pretty incredible. And this guy's pecker's fucking enormous. Like, I mean, completely, like, unchained. I mean, when he fucking blows his huge syrupy load, it's like the fucking flying monkeys from Wizard of Oz. Completely breathtaking. Literally. So, Dr. Greenfield, what are you going to talk to us about today?
Well, that was a very verbose and flattering introduction, Graham, but it's actually interesting that you mentioned reproductive functions, because I'm here to talk about a genus of bacteria that actually produces a variety of very weird reproductive effects.
Okay, just for those of us who have Wikipedia open in the Next Over tab on Firefox, what is the name of this genus?
Well, the genus of bacteria is Wolbachia, and it primarily infects arthropods.
Okay, for those of us who have a second Wikipedia tab open, what are arthropods?
Well, Arthropoda is a biological phylum. So it just contains organisms. Insects are there, crustaceans, spiders.
Okay, and you mentioned that this genus of bacteria had interesting effects. What effects are we looking at here?
One effect that they have is that with males that they infect, they tend to kill off males that are infected.
Nice.
Another effect that they sometimes have, they don't kill off the males, they can feminize them. So they can manipulate their hormones, their endocrine system, and effectively turn them into females that produce eggs.
So when this happens, is there some sort of identity crisis that you witness in these populations? Like, they start trying on their sister's clothes first, and then, like what sort of is there a psychological experience?
I don't think any have really been observed.
Okay. So besides feminization, what other things does Wolbachia do to an insect population?
Another interesting effect that it has is it allows, again, males that have been feminized and females to undergo reproduction without the assistance of a male. So in biology, it's called parthenogenesis.
Parthenogenesis, okay. And so parthenogenesis is like a virgin birth, so to speak, to use?
Yeah, actually that's a phrase that does get tossed around quite a bit.
Okay, so what more specifically goes on during a parthenogenetic sort of episode?
Okay, well, the organism just kind of reproduces on its own, okay. But it's essential to stress that these aren't clones, so there's still kind of in a manipulation or an exchange of gametes there, a reshuffling. So, for example, take for instance in mammals, right? We have males are what's called the heterogametic sex.
Okay.
So we have a Y chromosome and an X chromosome. Females have both X's. I mean, it's commonly known, but
one should hope.
that's universal among mammals.
Okay.
It's not universal among other animals. Okay. So, a lot of insects, for instance, females are that way. So if you have a parthenogenic female, the female can actually give birth to a male because, it's, let's say the female has X and Y chromosomes.
Okay.
Okay. So then, if it splits an X and combines an X, and that actually produces a male. So you can actually, yes, have something that's like a virgin birth.
So and there is some diversity. There's not just a sort of a series of clones being produced.
Right. Well, there's less genetic diversity, certainly far less genetic diversity than if you had, two organisms involved. One evolutionary benefit of parthenogenesis is it's just that you can reproduce by yourself.
Mm-hmm.
The drawbacks, one is that yes, there's less diversity.
Okay.
Another drawback is that if some sort of virulent organism if something affects the genotype of these organisms, it can be pretty rampant. I mean, Wolbachia is an instance of that.
So, sort of an aside, has parthenogenesis ever been observed in mammals?
No.
Not once?
No.
Ha! Anyway, besides Parthenogenesis, is there any other are there any other interesting effects? And also, what makes Wolbachia interesting to scientists? Why do they sort of latch on to it?
Sure, microbiologists are interested in Wolbachia for two main reasons. One is it catalyzes, speeds up speciation. So speciation, yeah, I mean that's essentially how evolution works. And how Wolbachia does this is that the males that it infects can't reproduce with females that are uninfected. So an infected male can reproduce with an infected female female can reproduce on their own, infected female can reproduce with an infected male. So in that way, Wolbachia kind of proliferates itself, and because it sets up these reproductive barriers, it triggers speciation.
Okay, so for those out there that believe the world was, say, created about 6,000 years ago, would Wolbachia be something they could look into to kind of disprove this fact about the worldview? Like, could they take something away from this example?
Well, first of all, at this point in our cultural history, if someone thinks that the Earth was created 6,000 years ago, the first thing that you do is you send them to the intellectual kids table.
Okay.
Yeah, just kind of trump them aside
okay.
that way. But if you want to invite them back in the goodness of your heart, after you've set loose a few BBC correspondents.
Yeah, if you feel like we're particularly charitable that day.
No, I mean I don't think that Wolbachia would have anything, would be involved at all in kind of a refutation of evolution or anything like that. I mean, speciation, although it's hard to bring about, has been observed in controlled environments, and there are organisms, Drosophila, which is a fruit fly, for example, a model organism among biologists, primarily geneticists, that reproduce much faster than humans do. So, I mean, you can isolate them within certain conditions, and you can literally create new species that way. It's not, I mean, there's always this distinction between, like, well, you can have microevolution, but not macroevolution, right?
But isn't that sort of like, believing in minutes but not believing in hours?
Sure, yeah.
Okay.
I mean, because a species is just kind of loosely defined as organisms that can't really reproduce effectively with each other and produce fertile offspring.
So
I mean, I don't know. It's unclear to me what else you would look for. So,
I mean, people are looking for bearded men in the sky. I mean, who knows? Who knows? And you notice that there was a second thing you said that makes Wolbachia interesting, and what would that be?
The other thing that Wolbachia is used in is that it's sort of there's some interest in using it to kind of control insect populations to some degree. I mean, it's not an outright eradication of these insects, but one thing it's used for is it's used as what's called a genetic vector. Okay. So you can take genes that we're interested in, insert them into Wolbachia, and create a recombinant organism.
Okay. For those of us who have a third Wikipedia tab open after the first two, what is a recombinant organism?
An organism whose genes have kind of been rearranged. It has genetics from kind of outside material. So. Or an outside organism. So if we use Wolbachia as a vector, we can insert it into insect populations that we're then interested in to kind of have this, we can put genes that we're interested in and watch them proliferate within insect populations for whatever reason that might be. There are some relevant interests in terms of treating, I mean, I don't know that this has actually been proposed, but if you have, other bacteria that sort of proliferate and use insects as hosts that are harmful to humans, then Wolbachia can certainly probably be utilized to help with that.
Okay. Well, that's what wraps it up, both the purely scientific and the possibly practical aspect of this very interesting microorganism. Again, I am a layperson, Graham. This is Dr. Greenfield, and it's been a pleasure having you.
Yeah, well, thanks. It's been a pleasure to be on the show.
Beast of the week.
This week's beast is Julius fucking Caesar. This guy ran shit, and I mean completely and totally ran shit in the Roman Empire. He manipulated people, like raised armies, lost armies, destroyed people, killed people, had sex with lots of women, and eventually he was killed by, some fucking peckerwoods. Anyway, great life story, great inspiration, great all of that. Check him out on Wikipedia, kids. Yeah!